All right, so we've talked about the rock cycle and how rocks go through a process from changing from one type to another. So typically, we kind of mark the beginning of the life cycle of a rock by being an igneous rock. So igneous comes from the Latin word for fire. So it starts from the fiery magma that is deep below the surface. All right, so origins of igneous rock. Igneous rock forms from magma. So magma can form in three different ways. So the first way, when rock is heated, when pressure is released, or when rock changes composition. So you can see the diagram over to the right. Temperature is the first one. When it's heated, a rise in temperature can cause the minerals in a rock to melt. Different melting points cause some minerals to melt while other minerals remain solid. Pressure, the high pressure deep inside the Earth forces minerals to remain solid. When hot rock rises to shallow depths, the pressure in the rock is released and the minerals can melt. And the third way is the composition. So, when fluids such as water combine with rock, the composition in the rock changes, which lowers the melting point of the rock enough to melt it. So, those are the three ways that magma forms. When magma cools, it solidifies and forms an igneous rock. So, liquid magma then has many minerals mixed in it. All right, so if we take a look here, composition and texture of igneous rocks. The rocks in the diagram are all igneous, but they differ based on what they're made of and how fast they cooled. So light colored rocks that you can kind of see up at the top too, the light colored rocks are less dense than the dark colored rock. The light colored rocks, we call these felsic rocks. They're rich in silicon, aluminum, potassium, and sodium. So again, we call those felsic because they're light colored. Um, Dark colored rocks are rich in calcium, iron, and magnesium, but they're poor in silicon. So we call those mafic rocks. Okay, fine grained versus coarse grained igneous rock. So, the longer it takes for the magma or lava to cool, the more time mineral crystals have to grow. The more time that they have to grow, the larger the crystals are, and the coarser the texture of the resulting igneous rock is. So, think if it took a long time for it to cool, then it had a lot of time to crystallize. So in contrast, the less time that magma has to cool, the less time crystals have to grow. The rock that is formed will be very fine grained, or a lot of times very smooth. Fine grained igneous rock contains very small crystals, or if the cooling is very rapid, it may contain no crystals. Um, so you can kind of see in the diagram to the right, coarse grain igneous rock that's um, cooling very slowly down at the bottom is very, very coarse grained, slow cooling magma. Fine grained is typically from lava that had to cool very quickly on the surface. So at the top of the diagram, you see it's pointing to the fast cooling lava. Typically, those are fine grained, smooth. Obsidian is an example. It's very smooth, doesn't have time to crystallize because it cools so quickly. All right, so you can kind of see fine grained. You have rhyolite, which is very fine grained, and basalt. Those are fine grained. They are igneous rocks, but you can see they're just not very crystallized and kind of uniform in their look. Then on the right side, you have the more coarse grained. Gabbro and granite are very, do you see how they're very coarse grained? There's lots of lumps in there. Those are crystals. So they've had time, they cooled very slowly because they had time to form those coarse grains, those crystals. All right, so we've got two types of igneous rocks we're going to explore here. Intrusive igneous rock is the first type. So, intrusive igneous rock forms when magma hardens below the surface. So, we're typically talking slow cooling because it's still underground where it's still warm. So, granite is an example. Intrusive igneous rock. So, you can see in the diagram over here, the stock here. You can see that this is igneous. It's a igneous rock intrusion, and what's happened is it's slowed very coolly. So okay. Now, extrusive on the opposite side is a rock that forms from lava that's erupted above the surface. So they're very fine grained because it cools very quickly. So you can kind of see basalt over there on the right. You can also think like pumice. Um, there's even though pumice is very porous and very holy, it doesn't have crystals in it, so it cools very quickly. So you can also think obsidian, so volcanic glass. Those are rocks that are very smooth. They did not have time to crystallize. Okay, all right, so that concludes our notes on igneous rocks. So make sure you filled in your notes and let me know if you have questions.